Yesterday, one of my students, Shabil from Sharjah. Wow, that just rhymed, right? Shabil from Sharjah. Anyways, so he sent me a question and it was about polynomials. When I sent him the solution, it just rang a bell that most of them who are going to give their board exams in like 2 days have absolutely no idea about this concept. To be honest, when I was a student, I had no idea about this concept. I just learned it over the course of time. I don't want you to learn it that late. So that's why this video. Hello everyone, welcome to Leap, where you learn once and remember forever. I am Deepika, a mathematics educator based in Melbourne, who tries to make math AEAP as easy as possible. Let's get into the video. This is the question I received from Shabil. You can see that there is a given polynomial, and the question is to find out which among these graphs is the graphical representation of the given polynomial. In order to solve this question, you have to first understand the concept. Let's do that. Let's see how we usually find the number of zeros when a graphical representation is provided. You can see that in this question there are 3 different graphs and we are supposed to find the number of zeros in each case. Let's look at where the graph meets the x-axis. If the graph does not meet the x-axis, then that means there is no zero. And if it meets, then as many times as it meets will be the number of zeros. The first graph, you can see that the graph does not meet the x-axis. This is your x-axis, but the graph does not meet your x-axis. So that means this has 0 zeros. How about the second one? So you can see that the graph meets the x-axis here, and then here, and then here. So that means there are 3 zeros. And in the third case, you can see the graph meets the x-axis at 2 different places. So that means this particular polynomial has 2 zeros. Now this is very easy. Let's look at this example. The polynomial here is already given in its factorized form. So you can see the factors are x plus 1 and x plus 3. Whenever you have factors, in order to find zeros, you just have to equate those factors to 0. As I equate the first factor, x plus 1 equals 0, I transpose 1 to the other side, the positive 1 becomes negative 1, and x is equal to negative 1 is one of my zeros, and the same if I do with x plus 3 equals to 0, plus 3 transposed to the other side, it becomes x equals negative 3, and that's my second zero. So as you look into this graph on the right hand side, you can see that it is meeting at negative 3, x equals negative 3, and it is also meeting at x equals negative 1. So there are 2 zeros for this polynomial, and both of them are distinctly spotted. Now this example again, this is similar to the previous example. You have 2 different factors, equating them to 0, you get x equals 2 and x equals negative 3. And you can see in the graph as well that it's meeting at negative 3 and it is meeting at positive 2. So there are 2 zeros. Now, when you have cases like this, where they are meeting at different distinct points, when the graph is actually cutting through the axis. So when we say that the graph is cutting through an axis, so cutting through is like literally cutting across x-axis. That means they have got distinct roots. So this negative 3, negative 1, and positive 2, they are all distinct roots. You can see here. But what if your graph looks like this, where it is a curve that is touching the axis, but it is not cutting across the axis? Here you can see this is the given polynomial in the factorized form. And when I simplify this, I get x equals 1 and x equals 1. So when I say x equals 1 and x equals 1, I see that the roots are repeated. It's the same. The graph actually touches as a curve on the 0. Whatever is your repeated 0. Similarly, one more example, you can see that x plus 2 is factorized form of the given polynomial. When I solve it, I get negative 2 as my repeated zeros, and my graph will look like this, where the curve touches the x-axis at negative 2. So it is not cutting across the axis, rather it is just touching the axis. Now let's try to solve the question that Shabil sent. We should be able to solve it. To begin with, let's simplify the given polynomial. So the given polynomial says x minus 1 the whole squared times x plus 2. When you simplify this, you get x minus 1 times x minus 1 because it is x minus 1 the whole squared, and then x plus 2. So the polynomial is in factorized form. You have to find the zeros of the polynomial. How do you find zeros? You just have to equate each of these factors. So when you equate x minus 1 to 0, you get x equals positive 1. Similarly, when you equate x minus 1 to 0, you get x equals positive 1. Again, x plus 2 when you equate to 0, you get x equals negative 2. Alright, we are done with the zeros. Here you can see that 1 is a repeated root and negative 2 is a distinct root. That means that your graph will cut across negative 2 on the x-axis, but it will touch the x-axis at 1 for repeated roots. Let's look at the first one. You can see the graph is cutting across negative 2 and cutting across 1, showing that it has only 2 zeros, but we have 3 zeros. So this is not possible. Let's look at the second graph. So you can see the graph is touching as a curve at negative 2. What does that mean? That means negative 2 is a repeated root. Is negative 2 a repeated root here? So you can see 1 is repeated, negative 2 is not repeated. So this is not possible. Let's see the next case. So you can see negative 2, the graph is cutting across once, showing that it is distinct, which is true. And you can see at 1, it is touching the x-axis as a curve. That means it is a repeated root. So that satisfies your solution. Let's have a look at the last option as well, just to make sure that you understood. So you can see here the graph touches the x-axis as a curve with negative 1 on the x-axis. But your answer does not have a negative 1 as a root. It's positive 1, which makes it wrong. So the correct option is option C. I guess you are now clear about what it means to have a graph touch an x-axis like a curve or cut across the x-axis. Thank you for watching. If you like this video, please give a thumbs up. And please follow Leap to learn more and make math AEAP as easy as possible.